9.5 notes, solving trigonometric equations, page 2. We've got 4 examples on this page. This gives us the chance to kind of refresh in our memories how to solve equations algebraically. You guys are probably pretty good at that. We have not done a ton of that this semester so far. And so we're going to kind of combine what we know about trig functions with what we know about algebraic equations. Okay, so example 2. We want to solve the equation exactly. Keep in mind that when you see exactly, the book and the homework are referring to exact solutions as we would see them on the unit circle. So you're not plugging anything into the calculator and cranking out a decimal. Okay, so we want to solve for theta. We've got stuff that we need to take care of here. So if we start with 2 cosine theta minus 3 equals -5, again, you don't need to show every single step. I will, just in case you look down to write something, you look up, and you've missed what I've said. Happens all the time. So now we're going to what? Divide by 2? Sounds good. So I got cosine theta equals -1. There's only one place on the unit circle where cosine of theta is -1, and that's where theta equals pi. Okay. Keep in mind, we could have gone the other direction. Theta could have equaled -pi. That is not in our interval, so you do want to make sure that you are paying attention to the parameters or the boundaries on your interval. Example 3. Solve the following linear equation on the interval 0 to 2 pi. 0 is included, 2 pi is not. Okay. So I've got 2 sine x plus 1. I'm going to move that 1 to the other side. I'm going to divide both sides by 2. I got the sine of x equals -1/2. Important to take a breath for a minute. Just remember where sine is negative. And write myself a note here. So I know that the sine is negative in quadrant 3 and quadrant 4. So I'm going to make sure that my answers fall in those 2 quadrants. So sine is 1/2 at my pi over 6's, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. The only 2 that are in quadrants 3 and 4 is 7 pi over 6 and 11 pi over 6. I'm going to go back up and double check my problem statement. We want this solved on the interval 0 to 2 pi. Both of these lie in that interval. So I'm done. Example 4. Okay, now notice this one doesn't say solve the linear equation. It's not linear, it's quadratic because we've got the sine squared in there. Again, we're solving on the unit circle from 0 to 2 pi. I'm going to start this like I would any other quadratic. So I've got 2 sine squared theta minus 1 equals 0. I'm going to move the 1 to the other side and divide by 2. Okay. Now I'm going to take the square root of both sides. And I'm going to remember that as I do that, my result here could either be a positive or a minus. Square root of 1/2, which is positive or minus square root of 1 over square root of 2. We don't like that radical in the denominator. We've seen that before. So we're going to multiply numerator and denominator by square root of 2. We get plus or minus square root of 2 over 2. Okay, we had to get that to the point where it looked like something that we've got on our unit circle. So I want to know where the sign is positive or negative. That's going to be all four quadrants. So here, sign is positive square root of 2 in quadrant, positive square root of 2 over 2 in quadrant 1 at pi over 4. It's positive in quadrant 2 at 3 pi over 4, and you can refer to the unit circle if you need to pull these values out. Again, you guys, if you are going into calculus, you do want to make sure that you know the unit circle well enough that you could crank these values out without referring to your unit circle. So there are two positive square roots of 2 over 2. It's negative in quadrant 3 at 5 pi over 4, and it's negative in quadrant 4 at 7 pi over 4. And that's it for example 4. Example 5. I'm going to try very hard not to write down into the margins because I realize that sometimes that gets cut off when you try to print. So cosecant theta equals negative 2. I'm not super comfortable with my cosecants. Again, I focus on sine and cosine. I can crank anything else out from that. Cosecant, though, is 1 over sine. So I'm looking for where the 1 over sine theta is negative 2. And I'm going to write it this way, negative 2 over 1. Because if I have two fractions that are equal, right, two ratios, I can just flip them over. So sine theta over 1 equals negative 1/2. I know where the sine of theta is negative 1/2. That's 7 pi over 6 and 11 pi over 6. And now I'm going to go back and reread my problem statement. It says solve the following equation. Cosecant theta equals negative 2. I've done that. But now it's looking for values that are between 0 and 4 pi. I found the two values that are between 0 and 2 pi. And so to find my other two values, I'm just going to go one more time around the circle. So I got 7 pi over 6 plus 2 pi. So 7 pi over 6 plus 12 pi over 6. Again, 19 pi over 6. Co-terminal was 7 pi over 6. And I've got, what's my other one? 11 pi over 6 plus 2 pi. 11 pi over 6 plus 12 pi over 6 gives me 23 pi over 6. So I actually have four values here. I'm going to add these other two on. I got 19 pi over 6 and 23 pi over 6. So there are four solutions between 0 and 4 pi.